Hey guys, in today's lesson, I want to go ahead and just kind of prepare you guys for your AP exam, and we're going to look at analyzing problems that have to do with the definite integral. You'll definitely get a problem in FRQ regarding this. So we just got to understand position, displacement, total distance traveled, as it relates to the integral and velocity. So I just have a kind of quick understanding here. To find the new position of a particle moving on the x-axis, what you're going to do is you're going to add the starting position to the integral of velocity. Remember, when you integrate velocity, you get position. Okay, so if you want to find the new position of a particle, the position, you're going to integrate the velocity, and you're going to also add where it starts at. And this will make more sense as we do the mathematics behind it. In order to find total distance, that's a key word there, you're going to have to integrate the speed, okay, which is absolute value. And that makes sense because when you go left, right, back and forth, okay, you want to add all those distances traveled. So you're going to have to use absolute value. Okay, so total distance, okay, you're going to integrate speed, which is absolute value, all right? And then lastly, to find change in position, okay, from one point to another, all you're going to do is integrate velocity over the time interval. And this is also called displacement. All right, let's take a quick look at an example, because you probably will get something like a piecewise function or a graph. It says that a particle moves along the x-axis so that at time t its position is given by x of t and the velocity v of t. At time t equals 2, the particle is located at x equals 6. The graph gives the velocity over the time interval from 2 to 9, okay? And we got to answer these questions. And I just kind of solved it. I'll go over it. Hopefully it makes sense. It says find the total distance traveled by the particle from 2 to 9. Okay, so here's the key word, total distance. What do? You absolute value of velocity. Okay, from where to where? From 2 to 9. Now, in this case, it's a graph, right? So what do? Well, when the integral is the area underneath the curve, so you're going to have to find the area of this guy. So it's 1, 2, 3, 4, 1, 2. So 4 times 2 is 8, and half of 8 is 4. What about here? 1, 2, 3, and then 1, 2. So 3 times 2 is 6. Half of 6 is 3. Okay, now normally, remember, area underneath the curve is negative, but because we're talking about the total distance traveled, okay, you have to add those units. So 4 plus 3, the answer would be 7. Whatever, 7 units, that's the total distance traveled. All right, letter B. It says find the position of the particle at t equals 7. Where is the particle located at 7? That's what it's basically asking you. Where is the particle located at t equals 7? So what you want to do is, essentially, you want to go ahead and integrate velocity. So let me go ahead and do it this way here. So without doing this here, they give us this, right? So at t equals 7, what do they give us? Well, it goes from 2 to 9. Okay, all right. And actually, this should be 9. Sorry, guys. I was looking at another problem. At t equals 9, where is it located? All right. So what we're going to do is we're going to integrate, okay, from 2 to 9, we're going to integrate the velocity. Because that's when we integrate velocity, we get position. Okay. Well, remember, when you integrate, the antiderivative of velocity is position. So you're going to get x, which is position, of 9 top minus bottom, x of 2. Okay. So now what I'm going to do is I'm going to rearrange this in order to solve for the position at 9. Okay. So this guy, I brought him to the left, and I got this x plus 2 plus the integral is going to give me the position at t equals 9. You see how I did that? I'm taking this guy here, moving him to the left, becomes a positive. All right, then you have x of 2 plus the integral of this. Well, what's x of 2? It tells us, see, at t equals 2, the particle is located at x equals 6. So now, and I'm sorry I ran out of room, what we're going to do is, I'll do it right here. 6, okay, which is this guy, x of 2, plus, now how do I find the integral of this guy? Well, I'm going to do the area underneath the curve. All right, now remember, this is not absolute value, so we're going to add plus 4 and then take away 3 because this is below the x-axis. 6 plus 4 is 10, minus 3 is 7. Okay, so at t equals 9, this guy is located at x equals 7. All right, and it just so happens to be the same as letter A. But notice how I did that. Okay, normally we're taking the antiderivative of velocity to get position. Okay, we did the fundamental theorem, rearrange this guy, and we're able to solve it. Remember, x of 2, okay, that's where it's starting at. It tells us that the position is 6. And then how do I do the antiderivative? Well, they gave us this guy. We're going to just do the area underneath the curve. So let's look at another one. How do you find the change in position from 2 to 9? All you got to do is do the antiderivative from 2 to 9. And if we look at that, okay, what's the change in position? All right, and we already know that here it's positive 4. Right here it's negative 3. Okay, so all it is 4 minus 3, which is 1. So the displacement is 1, or the change in position is 1. Okay, let's take another look at it in using a table. Okay, it says a particle moves along the x-axis so that at time t its position is given by x of t, velocity v of t. At t equals 3, the particle is located at x equals negative 2. All right, the table gives the velocity of the particle over the time interval from t equals 3 to t equals 9. If the integrals are approximated using left Riemann sum, okay, that's important, determine the following. Letter A, find the total distance. Okay, total distance, remember, how do you find that? Well, total distance is the integral absolute value of velocity, okay, dt. From where to where? From 3 to 9. Cool. Well, how do you do that? Well, that's a table. Okay. Well, what you're going to do is you're going to go ahead and you're going to use the left-hand Riemann sum, okay, to find the area underneath the curve. All right. But they don't give us a curve. They gave us a table. So all we're going to do is we're going to find the integral. All right. We're going to find the area. So imagine you have all these rectangles from 3 to 9. We only have 2. And that's going to give us the area underneath this integral, underneath this curve. Well, how do you find left-hand Riemann sum? Remember, it's base times height. Your time is always your x. Your velocity, that's your y, okay? So base times height. And it's saying it's left hand, right? So we're going to put a dot right there, a dot right there. So what's the base? From 3 to 5, what is that distance? 2. What's the height? The height is this guy here. Well, what are we using? We're using the left hand, so we're going to be using negative 5. Plus, now we do the next one, from 5 to 9. That is a distance of 4 times 7. Okay? So we found the area underneath this curve. So 2 times negative 5 is negative 10 plus 28. And that should give you positive 18. So the total distance traveled for, actually, this guy wouldn't be 18, right? This would be the displacement, because what are we doing? Absolute value, right? So this would actually be 38. Sorry about that, I'm moving too fast. But notice, why is it 38? Because it's absolute value. Absolute value, okay? Absolute value here, absolute value here. So the total distance traveled is 38. Find the position, letter B, at t equals 9. Well, how do I find the position? Well, where are we going from? We're going from 3 to 9. Okay, so we're going to do the antiderivative from 3 to 9. Vt dt. That's going to give me x of 9 minus x of 3. I want to find out the position at t equals 9. Okay, so rearrange this guy, move the negative, this guy to the left. So we're going to get x of 9 is equal to x of 3 plus the antiderivative from 3 to 9, vt dt. Now, what's the position at 3? It tells us. It says at t equals 3, the position is negative 2. Okay, so we're going to have x of 9. We're going to have negative 2 plus. Now, what's the integral from 3 to 9? Okay, this, we're using our Riemann sum again, okay? Remember, this is not absolute value anymore. So this, we're going to use the same thing over here. So it's going to be also negative 10 plus 28. which is going to give us 18. So now we're going to add -2 plus 18, and that's going to give us 16. So the position at t equals 9 for this particle is going to be at x equals 16. All right. Notice how I did that. I did the integral of velocity to find position. I did the fundamental theorem. I rearranged this guy. And now I just use what they give me. The only caveat is going to be, well, how do you take the antiderivative? Sometimes it'll be a table. Sometimes it'll be a graph. Normally, it's a graph, and you're going to have to find the area underneath the curve. All right, let's do letter C. Find the change in position. Keyword, change in position between 3 and 9. What do? Change in position, just the antiderivative of velocity. Vt dt. And that's all you do. All right. In this case, they gave us a table. So I did my left-hand Riemann sum. And we did it already. Okay, so it's going to be -10 plus 28. The change in position is going to be 18. Okay, so that's how far it traveled from its location, from 3 to 9. Okay, just that those two distances, 18 units. Okay. All right, let's keep going, guys. Some things I want you guys to understand, just moving forward and understanding these problems. Position, okay? You got to understand position is the location of a particle on the number line, where it's located. A lot of times they'll ask, where is the particle located at t equals 4 or 5? Okay, where is the particle located at this point? So they're asking for position. Okay, now it can be negative since the location can be to the left of the origin, all right? So that's okay if it comes out to be negative. What do? Well, remember, position, you're taking the antiderivative of velocity. It gives you the fundamental theorem. You rearrange it, and that's what we've been doing. Okay? Sometimes you'll see x prime of t, which is the same thing. X prime is same thing as velocity. But this is an example here that I gave you. So if I do the integral from 3 to 7 of Vt dt, I do the fundamental theorem. All right, and then I rearrange it. All right, bring this guy to the left. Now I have x of 7 is equal to this. This is going to give me the position at t equals 7. And it makes sense because we got to know where it's starting and then how much it traveled in order to give you an idea of its position. All right, so hopefully that makes sense. Displacement. Displacement is the difference between the ending position and where it starts. Okay, so just between 1 and 5, like what is that distance covered? It also can be negative, okay, depending, okay, if it's to the left of the starting position, okay? And this is just change in position. All you got to do is just do the antiderivative of velocity. And this gives us the change in position from t equals 1 to t equals 5. And then next one is total distance. Total distance, easy. Remember, it's absolute value. This is the sum total of all the distances traveled, going to the right, going to the left, okay? And then because the integral is, or the integrand is absolute value, it's only going to be positive, okay? And that makes sense. Distance, total distance is going to be positive. All right, it can never be negative. All right. Couple of other things. In finding speed of a particle, you're always going to use absolute value, okay? Because think about it, speed is distance over time. All right. Now we need a total distance traveled to figure out what is the average speed. So when they ask for average velocity or average speed, in this case, average speed, okay, would be come from the average value or the mean value theorem, 1 over b minus a. Or from a to b of the function, the antiderivative of the function. And that makes sense because total distance, right, is given by this guy divided by time, which is the x values. So distance over time. And so when they ask you for find the average speed of the particle, it's going to give, you're going to use absolute value, okay? If they say find the average velocity of the particle, you will not use absolute value, okay? So average speed of the particle, okay, you're going to do absolute value. Average acceleration of the particle, same thing. Average, that's a key takeaway right there. You're going to use the mean value theorem, and it's 1 over b minus a and the antiderivative of acceleration, Okay, because remember, acceleration is the change in velocity. Okay, what is velocity? Velocity is a change in position. So when we take the antiderivative of velocity, we get the change in position. So hopefully, guys, that makes some sense. Go over it, make sure you understand it, and I'll go ahead and make another video with some more examples from previous AP exams so that way we can get the hang of how to do these problems. All right, guys. Thank you.